Hey, this is Jeremy here at Chronulus. Wanted to walk through a new use case today. So last week we went through this little use case with a imaginary coffee shop. The idea being that they're trying to launch a new croissant or a new item. It could really be anything. And just kind of walking through what that would look like as we chat with Chronulus through Claude Desktop. So that was last Thursday. I'm going to back up a little bit today and talk a little bit more about what's going on under the hood. So if we kind of take a look at what we offer at Chronulus, so this is just on our website here. What we're providing is a Python SDK, Python package that you can download and install, and then basically walk through a very basic forecasting use case. The first step being describing the situation and task. Imagine you're hiring someone, right? Writing down a job description. You're going to detail what your company's about, what your team's about, and then start writing down individual sort of tasks that the person might accomplish while they're working on the team. And so that's kind of how you would differentiate between the situation aspect of the session and the task aspect, right? So the task gets a little bit closer to the type of thing that the agent will be performing, but it leaves out sort of the raw details. You're not giving the actual inputs, the individual data pieces that you would be using to forecast. So that's defining the session. The next step of the process is to define more of that, the individual inputs that the agent will be operating on. So here in this particular example, we're forecasting demand for some dog treats. And so we're going to define like this little data model, and the data model is going to include the name of the treat, the description of the treat, and the price that it's sold at. So that kind of gives the agents the overall situation and task, and here's like the raw components that you're going to operate on when you create your forecast. The third step is to actually give the agent, after it's created, give it access to the information that you told it you're going to give it access to. So actually filling out the name of a treat, a description for it. This could be a description that you're iterating on. Maybe you're adjusting the price and trying to figure out how the price might impact or the elasticity of demand based off of the price, right? All very relevant things for forecasting. And then you'll feed that into the actual forecasting agent, giving it an idea of the time horizon, the forecast horizon over which you want the forecast. So here we do that by just defining a starting point. This is the first forecast period that we want included in the horizon. And then the duration. The duration is defined in number of time periods. Here we want to get the forecast over 52 weeks, but Chronulus also supports hours, days, and weeks at the moment. So you can really ask the same agent to reproduce the same forecast on an hourly basis or a daily basis or a weekly basis at the moment. You just reuse the same agent to do all of those things. At the moment, you submit that particular data point to Chronulus, wait a little bit, and you're going to get back a prediction. So the final piece of this is collecting the prediction and plotting it. Here on our website, we show an example of plotting that prediction in Python, so you don't really see the underlying data components. And we also get a prediction explanation back. This is Chronulus telling us what it baked in to that particular forecast. So thinking about what we're actually doing in Claude, we've created a package, we've created an integration with Claude where Claude can now put all of these inputs that I've just walked us through. It can take those inputs out of your conversation and distill them and give them to Chronulus. So let's go back to the croissant explanation here, or use case, and let's go back and look at some of these outputs. So for example, creating the Chronulus agent and getting a forecast. So what we see here is Claude actually defining the components of the forecast horizon, right? So you saw that particular step. It defined those components for you. It created a data model. It basically decided what types of features it wanted to pass on to Chronulus. And then it's a little bit out of order here. It also passed in the individual data inputs that it wanted to provide to Chronulus. So it made all those decisions dynamically for you as you're kind of stepping through the process. And it also, at the very beginning, created this session for us. So based off of our chat, it pulled those details out and it kind of broke those apart into the situation and task for us. It's not always perfect. We're working on making it better, basically giving Claude better instructions for how to use our tools and really trying to streamline that for you. But it's pretty cool that this is already possible. And I think it's going to enable a lot of really cool functionality for people as they start to get more used to using Chronulus and more used to using tools inside of Claude as well. So moving on a little bit, I'm going to jump to another use case that I tried out after we kind of streamlined a little bit more of the process. I have another use case here. So I live in Brooklyn, New York, in the Williamsburg area. And one of the really cool aspects of New York, maybe not necessarily in the wintertime, but in the summertime when it's a little bit warmer, is that we have a ferry system. And so there's a series of ferries and ferry routes. They go up and down the East River and the Hudson River. And, you know, if you live in Brooklyn, sometimes it's faster actually to take a ferry to work than it is to, you know, jump on a subway and then, you know, hop over different subway routes. And so I thought it'd be really interesting to see if Claude combined with Chronulus could give us a decent demand forecast for how many people would be actually riding between the Williamsburg stop, which is kind of in my neighborhood, and the Midtown stop, which is where a lot of people work in Manhattan. So I just kind of started off the conversation a little bit indirectly here. I started off just asking Claude if it could estimate what the capacity for an NYC ferry boat is. So thinking ahead about like how would we actually start to break down that idea, that task, and give Claude some information about that. Here it kind of broke it down. I asked the question and it's kind of laid out the assumptions that it's giving us. Basically thinking that the average ferry boat kind of fits between 150 and 350 passengers. It goes through kind of what the overall schedule would be, thinking about how many times during the week the ferry might run. It didn't actually give us an overall capacity for the route per week, but this already kind of got Claude thinking about what it might do in that situation, right? And then beyond that, the next aspect here is I gave it much more clear directions in terms of like what we actually wanted to use that information for. So I said, hey, using Chronulus, can you forecast the daily ridership as a percentage of capacity for the East River Ferry between these two stops, right? And this is what our current agent is really good at. It gives really good forecasts, seasonal forecasts, sort of forecast factors. The individual outputs are going to be between 0 and 1, and that allows you to rescale those predictions to whatever your use case might be. So a lot of times it's really difficult to understand what the scale might be ahead of time. Like you just saw, Claude may have a lot of different assumptions that it might give to you, or you might want to do a lot deeper research. For example, maybe having another tool like OpenAI's deep research tool that goes out and gleans a lot of data around, what the actual capacity levels are, right? So there's lots of different ways that we can sort of arrive at a scale, but the underlying seasonality is already something that's super valuable to be able to predict and get that out and then scale it to the correct level that you need. So that's what we're doing here is we're going to get the seasonality factors out of Chronulus, and then we're going to ask Claude to use our rescaling tool to rescale those up to the capacity levels that we're going to assume maybe the ferry would have. And the next thing is we're going to tell Claude just, hey, let's forecast this over the next 10 days. So Claude's going to see this, see our request, and understand how to translate that into the code that we saw on our website. Here's some more assumptions that I gave it. Just assuming that we want to forecast ridership between different stops on the route. So this idea here is like trying to hint at Claude to set up the situation and the tasks such that we can provide different types of inputs. So creating a data model that allows us to plug in different stops and get different forecasts using the same agent. Which is, I think, how a lot of people will end up using our tool, just reusing the same agent over different items to get different results, and then compare those, obviously compare those results. So that's how I set up this situation, or this particular ask for Claude. And so the next thing that Claude did with that information is it created a session. So this is kind of slide 1. In our on our website, you can see here it's providing a name, tasks, and situation. So if you go back to slide 1, it's really just plugging that information into Chronulus and to create the session. The next thing it's going to do is going to take that information. It got back the session ID, and it's going to hand off that session ID to the next tool along with the input data, information about the time horizon, the forecast horizon, and the underlying data model. Is going to hand that off, create the agent, and then submit the forecast at the same time. So here Claude is basically combining steps 2 and 3 from our website, combining those together. So it created the data model and then created the input at the same time. Then we can see at the bottom, it got back our forecast along with an explanation. So that's pretty much taking us up to this point at the very bottom here, where our agent's getting the prediction from the request ID, and we're ready to do whatever we want to do with those. A really cool thing about using Claude for this is that it has the ability to plot data in different ways. One of the ways that it does that is to create React components. So React is a way of sort of creating visualizations in websites, right? So, I mean, probably the whole Claude website is actually built in React, and it's just creating a little component that it's able to use to display our forecast within Claude. I guess I skipped ahead a little bit here. So it actually got our predictions back, and then it realized that we wanted to rescale those. And so it called our rescaling tool, and it took its estimate for the number of passengers and number of trips, and it's told us here that it thinks that the total capacity for the ferry boat or for the route is going to be about 4,500 passengers per day. So I don't know if that's true or not, but based off of what it's kind of estimated, I think that's a good place to start. And so that's what it's going to do here. It's going to take our prediction that we just created. It's going to fetch that, and then it's going to rescale that so that we actually see the total number of units in the plot that we get back. So you can see that, and we get the same dates back, and then we get the predictions rescaled by the amount that was given to the tool. And then this is, like I was mentioning with the React component, this is the component that we get back from Claude. So it's taken a lot of liberties in how it's going to plot this for us. So here it's plotted the actual capacity utilization on the left-hand y-axis, and then the estimated number of riders rescaled here. All right. One thing I thought was really interesting was that we didn't give it any weather data. I don't think Claude is hooked up to use weather to be able to access the internet in any way. So it actually came in when it gave the forecast inputs up here. It created a weather forecast feature, but I think it sort of just made up weather forecast data over the next 10 days. And so that's maybe good to start out with, maybe like an interesting assumption. But one thing I found that you can do is you can just go out and take a snapshot of a weather forecast. And so that's what we did. I took a snapshot of the weather forecast here in Brooklyn for the next few days, and I just gave that to Claude and said, "Hey, could you pass this information to Chronulus?" And let's just reuse the same data model. I saw that you already have a feature included where you can, write down the weather forecast. So that's what it did. It basically looked at our image and it pulled out all of the information from that weather forecast, and it plugged that into our weather forecast feature, and then fed that back to the agent. So that's a really cool feature. Right now, we're able to basically feed Claude an image. It'll take that, translate it to text, and give that to Chronulus. One of the drawbacks that we've seen with using this right now is that we can't directly feed images to Chronulus from Claude. That's just, for a lot of technical reasons, not really possible at the moment. So I'm looking at a few different workarounds where we can actually move files and images and things like that between Claude and Chronulus a little bit more seamlessly. But right now, basically, if you give Claude an image or a file, it really needs to be able to distill that to text and only pass that text on to Chronulus, just because of where the technology is at the moment. So here, Claude's taken that new weather information. It's going to collect the forecast again, rescale it by the number of passengers, the capacity limit of the passengers that it's kind of worked out, and then we can plot that again. And so you can see that the forecast has now adjusted with the new weather information that's come in. Claude has changed the output here a little bit, just to make it a little bit easier to, let's say, compare the weather with the dates. And what else did I do here? So then I was interested. So there are actually open statistics for the number of riders per day from different stops here in New York. So I went actually and looked up what the number of riders were for that particular ferry route, and found that there was only about 1,000 boarders, people who board from this particular ferry stop that I'm at. And that was kind of at the peak season last summer. If you can imagine, probably the most tourists and people kind of moving around the city on a ferry is going to be probably around the 4th of July weekend. And that was about the peak that I saw. And so I was like, hey, Claude, can you rescale using Chronulus with 1,000 as sort of like the maximum ridership? Like, there might be a larger capacity on the route, but really in terms of like the number of people who are going to get on the ferry at this particular stop, I think it's probably going to be closer to 1,000. So let's rescale it to get a little bit closer to what that number might be. So we passed that number in. It figured out that we wanted to use 1,000 as the maximum, and we get back an adjusted forecast now. And then what we did, let me see here, what else did I do? I pulled in some actual historical data from last year over the same time period, and just to kind of sense check like where our numbers were at in terms of reality, right? So plug that in, and then Claude just kind of plotted those numbers alongside our forecast so we can see where they're at. One thing I found that was really confusing though is I grabbed the literal days from last year. So this year, I was forecasting from the 24th, February 24th through March 5th. That kind of doesn't make sense to plot those next to one another because they're going to be different days of the week, and so the patterns are going to be different, and that's you kind of see some messiness here in terms of like weekly cyclicality when we plot those forecasts. And so I actually revised what I gave to Claude, and I just pulled out the same days of the week. So really kind of shifting a couple days forward in time just to make sure that the dates and the numbers we're getting out, we're going to align with the days of the week that we're plotting for the current forecast. So that's what I did here on this next piece. I just had Claude replot those forecasts in line. And so here Claude calls these numbers 2024 actuals. Not really, I mean, yes, that these did actually occur in 2024, but they're not really, let's say, something that we want to baseline the new forecast against, right? Like, it gives us an idea of what we might be looking for, but it doesn't mean our forecast is necessarily wrong if it doesn't line up completely. The weather is very different on those days, and so that's what I did next. Is I pulled in the weather from last year. I gave those to Claude in the form of images, and now we can get a table. Claude added that weather to the table, so basically showing we can then get a sort of a difference, a little bit of perspective of, you know, last year we saw a dip in the numbers on this day. Well, it was cold and rainy. That makes a lot of sense. Why that would happen, and this year is maybe going to be sunnier on that day and a little bit warmer, and so we're going to see a little bit of an uplift in numbers compared to last year. So that was the next step here. One other thing that I pulled out from this was that based off of the stats that I could find on the public website, they only tracked the number of passengers that boarded. They don't, you know, I guess if you've ridden the ferry system, they check your ticket when you board. When you get off, you just get off. And so there's no way to track how many people actually get off at different stops, or at least that's not something that they do and put on the website. And so I actually asked Claude to go back and recreate the forecast in Chronulus, basically looking at any particular stop north of Williamsburg. So how the routes work is that there's one ferry that goes south along the river and another ferry that goes north. And so the Midtown stop happens to be on the northbound route. And so I thought, hey, let's just try to figure out how many passengers would be boarding from Williamsburg and just going to any stop that's northbound, right? So Midtown's very specific. It's going to be more commercial in nature, and the other stops are going to be maybe more neighborhoody, more residential. There's going to be different purposes for getting on at Williamsburg and getting off at those other stops. So maybe the nature of the forecast is going to be a little bit different. And so that's basically what I asked it to do here, is go back out, create another forecast based off of this change situation. Claude was pretty smart about this. I figured out what the other stops would be. So here for the destination stops, it put all northbound stops and it listed them. So 34th Street was the Midtown stop that I'd added before, and then it also included the other northbound stops along the route. So Long Island City, Astoria, and Roosevelt Island. So very, very impressed with Claude's ability to include that information and just extract that automatically. And then we get back, so it rescaled the predictions again. And then Claude decided to, this is all without me asking, Claude decided to plot all of our different forecasts together so we can compare them pretty easily, which was nice. I appreciated that. So we have the original Midtown only forecast here in purple. We have the forecast that we just asked Claude to recreate here in orange. And then we have the 2024 actuals, the historical data that we can kind of use it for a year-over-year comparison. Claude decided to call these forecast errors. I don't know if they're necessarily errors, but they are differences between what we observed last year and this year. So that's pretty cool. And then Claude came and it gave some analysis in terms of the different models. You know, basically breaking down how the models compared, which one was biased upward, which one was biased downward, and basically pointing out that the second model is more realistic in terms of temperature, precipitation, and I can't remember where it was, but also pointed out that the second model, where we considered all of the stops, because we included all of the different stops, there is less of an impact based off of weekday riding and weekend riding, just because there's fewer people going to Midtown on the weekends, just because there's fewer commuters, and so the type of traffic is going to be less sensitive. And also thinking about how that corresponds with weather effects, right? Like if you're traveling on the ferry to go to work, you're still going to travel on the ferry to go to work on colder or rainier days, just because that's something you need to do. If it's really cold, really rainy, yeah, you might take the subway or take a taxi, spend the money to take a taxi. But for the most part, people are going to be less sensitive to those weather effects if they're doing it for work rather than leisure. So I thought that was really nice that it broke out that analysis too. And that's kind of the rundown here for the notebook that I posted earlier this week. And hopefully that provides some better context in terms of how Claude and Chronulus are interacting, where kind of Claude is giving information to Chronulus and what information Chronulus is providing back to Claude. So thanks for watching.